Hello, this is Mr. Stansbury. I'm going to take you through the problems from section 19I. Alright, first one, number one, A, B, and C are points where tangents are horizontal. So tangents horizontal there, there, and there. Okay, classify the points A, B, and C. Alright, so A is down here, and A is a minimum of some sort, and since this graph here has got the arrow on it, that means it goes forever and ever. So that means it is a local minimum, right? Because there's actually these points over here are lower than that, so that makes it only local. Okay, point B over here, again, since this graph goes forever and ever up, that makes this a local maximum. Okay, and then point C here is where, again, it comes down here and it flattens out right at 0, and then it keeps going down. So that is called our horizontal inflection. Okay, so those are our 3 points, A, B, and C. Draw a sign diagram for the gradient of f of x for all the x's. Alright, now, not too super worried about the sign diagrams, but just in case it happens to show up on your IB test, let's draw one. Alright, so it's going up. Basically, we want to write down all of our x's, or x values of all of our turning points, right, where it stops going up and starts going down, our inflection points, and also our local and minimums, maximums, all that kind of stuff. Okay, so we can even write it right here underneath. So we've got -2. So here's make our line here. So there's -2. Here's 3, and then we also got another point here at 0. Okay, so our sign diagram before -2, this graph's going up. So this sign diagram over here is going to be positive. Between -2 and 0, it's going down, so that's negative. Between 0 and 3, it's still going down, so that's still negative. And then after 3, it's going up, so that's going to be positive. So that is our sign diagram. Alright? And then part C, state the intervals where f of x is increasing and where it's decreasing. So you can use your sign diagram if you want, or we can just kind of go back to what we were doing before, and basically, okay, we know this is increasing, this is decreasing, and actually still decreasing here, and then increasing here. Alright, so let's see if we're going to do that one. Let's just do that over here. So C, so we got increasing and decreasing. Right, so increasing when x is less than -2, and again, that's how you can see this here. There's the positive, so that means it's increasing. So when x is less than -2, it's increasing. When x is between -2 and 3, from -2 to 3, it's all decreasing. So from -2 to 3, but in there also we can't have 0, so 0 isn't actually in there. So let's do this. Let's change that 3 back to 0. So it's decreasing from -2 to 0, and then it's also still decreasing when x is greater than 0 but less than 3. Okay, so again, that's from -2 to 3, but not including 0, because notice neither of those have the equal sign underneath there. Okay, and then the last part here is increasing, and that's when x is greater than 3. There's our x is 3, and that's where it starts increasing. Alright? Alright, there's number 1. Number 2. Consider the function. Use the quadratic theory to find the equation of the axis of symmetry, and then find f prime of x, the derivative, and hence find x when the derivative equals 0, and explain yourself. Alright, so quadratic theory, what I'm pretty sure they're getting at here is we know that x equals -b over 2a. right? That's how we find our axis of symmetry is negative b over 2a. So part A here, we're going to do x equals, let's see, here's b, so it's negative 5, right, because there's b, all over 2 times a, and a is 2, so there's a and there's b, right? So that just gives us that x equals 5/4, okay? And that is the equation of the axis of symmetry, right? So again, not that they're asking us, but what that means is that we know, like if here's our graph, it's not beautiful, but you get the idea. There's 1, there's 2, about 5/4 is right here. So we know that somewhere down here, like right about 5/4 is going to be like either the minimum or, let's see, well, it is going to be the minimum because it's 2x squared. So it's a parabola that opens up. So right somewhere along this line here where x equals 5/4 is where the vertex, the turning point is going to be down there, right? Okay, part B, again, that's a little bonus coverage there. We really only had to find this. Okay, part B, find f prime of x. So we're going to find the derivative of this, right? So f of x is 2x squared minus 5x plus 1. So the derivative, 2 times 2 is 4. F prime of x is 4x. Remember, subtract 1 from that, so that's x to the first, or just 4x. And then that's x to the first. 1 times negative 5 is negative 5. Subtract 1 from that, and the x, that's x to the 0, so it's really just 4x minus 5. All right? All right, so I'm just going to get rid of that because we really don't need that. So there's our derivative. And then now it says, hence find x when f prime of x equals 0. Okay, so here's our derivative, and then we're saying f prime of x equals 0. So they're saying, okay, now plug 0 in over here, 4x minus 5. And now we're just going to solve that. So we add 5 to both sides, and we get 4x equals 5. Divide by 4, and we get x equals 5/4. Ooh, magic, just like what we got up here. So it says explain, right? So what we figured out when we have the derivative, right? When we take the derivative and we set the derivative equal to 0, that means the slope of the tangent is 0, right? So that's a horizontal line. So look, the only horizontal line of the tangent is going to be right here, right where it hits the vertex right there. So then we know that the tangent has to be right there at the vertex at the turning point. So that's where that's 5/4, which is our axis of symmetry as well. All right? Okay, that's number 2. Moving on to number 3. Each of the following functions, find and classify the stationary points, and then find the function, sketch the function showing all important features. All right? So what we need to do is take the derivatives of these. All right? So b is f of x equals x cubed plus 1. So the derivative of that, 3 times 1 is 3x. Subtract 1, and we get x squared. So there's our derivative, right? And then it says find and classify the stationary points, and then sketch the function showing all important features. So here's our derivative. And then remember, if it's the stationary points, that's all of our turning points. That's always when the slope of the tangent has to equal 0. So we're just going to set this over here equal to 0. So 0 equals 3x squared. When does 3x squared equal 0? Well, when that's only going to work when x equals 0, right? So then we know, since this is an x cubed, and it is a positive x cubed, we know that it ends up going up and to the right. So if we're just going to sketch it, it's going to look something. Again, it's going to really flatten out in here, right? And it's going to look something like that, right? And there's our one stationary point right there at 0, 0, our horizontal inflection, right? Let's see, I think that's really all the important features we need. 0, 0. Yeah, let's go with that. All right, I need to back up a little bit because we know that the stationary point is when x equals 0, but I didn't actually calculate and figure out what the y value would need to be, right? So let's undo this graph here really quick. Okay, so let's get rid of that. And then let's actually do what I was supposed to do in the first place and actually calculate what that thing was supposed to be. Okay, so we know that x equals 0, so to find the y coordinate, whenever we want to find the y coordinate, plug it back into the original function, right? So let's see, let's get rid of that graph for now. So to find the y, we plug it back into the original. So we got 0 cubed plus 1 is what our y value is going to equal, right? So our y value then is 1. So now we know that our stationary point, our horizontal inflection, is going to be at 0, 1. All right, so now if we go to draw that, then we have our graph here, and again it flattens out right there, comes back down. Why did I do it through the origin again there? That's 1, 0, there's the point 0, 1, so sorry, it's got to come down through here, kind of flatten out right at that spot, and then come on down like that. All right, and we know that that point there is 0 and 1. All right, so that's B. Let's see, let's try D. Let's give ourselves a little bit more room. So, same thing, take the derivative. So we got f of x is x to the 4th minus 2x squared. So now we've got to take the derivative of that. So 4x, 4 times 1 is 4. Subtract 1, that's x cubed. And then we go 2 times negative 2 is negative 4x to the 1st. Okay? And then again, finding the stationary points, we have to set, we know that the slope of, this is the equation for the slope of our tangent, right? And so we know that since it's a stationary point, this has to equal 0. So 0 equals 4x cubed minus 4x. So let's start by factoring out whatever we can out of this. And then in this case, we can get a 4 and an x out of both of these, right? So we've got 4x times, when you take that 4x out, we're just left with x squared, and then negative 4x over 4x is minus 1. All right? So we can factor this farther, because look, this is a difference of perfect squares. So that x squared minus 1 is going to factor out into x plus 1 and x minus 1. So look, we're going to have 1, 2, 3 spots where we're going to have stationary points, because we've got 3 places where the tangent, the slope of the tangent is going to equal 0. Okay, and so that's when x equals 4 times 0 will give us 0. Negative 1 plus 1 will give us 0. And so will positive 1 minus 1 will give us 0. All right, so now we've got three different points. Okay, and so then what we have to do is we actually have to plug all 3 of those points back into this original equation to figure out to find all the stationary points. Okay, so let's try that out. Let's do this in a different color to hopefully make it a little easier. So let's plug in 0. So again, we've got our function is this one right here. Okay, so we've got 0 to the 4th minus 2 times 0 squared, which is just going to give us 0. So this point here, we know we have a stationary point at 0, 0. Okay, let's do Another one here, and let's plug in -1. So we got -1 to the fourth minus 2 times -1 squared. So that's, see, -1 to the fourth is 1. -1 squared is 1 times -2 is -2. So that gives us -1. So another point is at -1, -1. Okay, so we've got 2 points. And then let's find the third one. That's where we plug in 1, right? So we've got 1 to the fourth minus 2 times 1 squared. So that's 1 to the fourth is 1. 1 squared is 1 times -2 is -2. And that also gives us -1. So our third stationary point is 1 and -1. Okay, so we've got all three of those points. And we're going to want to graph all of those on our graph. All right, so we get this here. So we know we've got one. Let's see. We'll do them in the same color. So here's our 0, 0 point. Okay, and then we've also got. Let's see. The second one we did was -1, -1. So -1, -1 is down here, right? Let's see. I should put some tick marks on here to make this a little bit better. Okay, and then we also have this last one, the green one here, and that was at 1 and -1. Okay. All right, so we know that this here is positive x to the fourth, so we know it ends up going up. So again, we're just sketching, and the only thing we're really worried about are those 3 points. So we're just going to kind of sketch our graph. We know it's going to come down here, go through there, again, because these are all points of inflection, right? It's going to look something like that. And then we're going to have, we'll want to probably label these 3 points. So this point here is our 0, 0. Right, this blue one right here, and then that one down there was our purple one here, and that's at -1, -1, right? And then we also have this one here at 1 and -1. Okay, and it says find and classify the stationary points. So this blue one here is that one there is a local maximum, right? Because these, again, this function goes up forever and ever. And then these two down here, since they both are the global minimums, they actually are both sharing it. So neither one of them is the extreme, the actual minimum there. So we're going to call both of those the local minimums. So local minimum here, and then this green one over here is also a local minimum. Okay, so we've got that, and then let's do F. All right, let's see. We're going to do this in a different color to hopefully make it a little less confusing. Excuse me. All right, so F here. Again, first thing we got to do is start by taking the derivative. So we got 4x minus x cubed. So that's 4x to the first. So the derivative on this thing is 4. And then you got x to the 1 minus 1, which is x to the 0, so it's just 4. And then 3 times -1 is -3. X to the, subtract 1 from that, and that's 3x squared. Okay. Stationary point, we know that the slope of the tangent there is going to be 0. So we get 0 equals 4 minus 3x squared, and we got to figure out when this here is going to equal 0. Now, I can't really think of much that is going to help us out factoring wise with this, so if I can't think of something that's going to factor, I'm just going to plug it into the quadratic. Okay, so in case you forgot the quadratic, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's plug what we know into that, right? So let's see, we know that a up here is negative 3. B, there is no b, so that's 0. And then c is going to be 4. So let's see what we get. X equals negative 0 plus or minus 0 squared minus 4 times a, which is negative 3, times c, which is 4, all over 2 times a, which is negative 3. Okay, so x is, the 0 is gone, so it's plus or minus square root of 4 times negative 3 is it's positive 12. 12 times 4 is 48, all over negative 6. All right, so let's see. Let's get our calculator and see what that actually is going to be. So take square root of 48 and then divide that by negative 6, and we get 1.15. And officially there it's negative, but if you'll remember, it's plus or minus that anyway. So x is going to be 1.15 and negative 1.15. So those are going to be our two x values. So we got to find the y values for both of those. So we got to plug that back in to this original equation. All right. So we got to do 4 times 1.15 minus 1.15 cubed. All right, so let's see what that gives us. All right, so let's see. That's not what I wanted. Sorry, let's see. All right, 4 times 1.15 minus 1.15 cubed gives us 3.079, so let's go with 3.08, right? And then let's plug in, so we know, let's see, so we know now that one of our points is 1.15 and 3.08, right? So let's plug in the other one, the negative 1.15. So we got 4 times negative 1.15 minus negative 1.15 to the third. All right. So 4 times negative 1.15 minus, let's see, we've got parentheses, negative 1.15 cubed. And that gives us negative 3.08. Right, so now we know we got negative 1.15 and negative 3.08. So these are our two points that we're looking for. Okay. So let's make our graph with our two important points, which are these two. It's kind of hard to see with all the other stuff in there. So those are the points we got to make. So let's make ourselves some room and graph those points. Okay. So again, as long as we're in the ballpark, we're good to go, because it is truly just a sketch. So we've got negative, here, let's do this in a different color. So we've got 1.15 and 3.08. right? And then we also got negative 1.15 and negative 3.08. Okay, so again, that's in the ballpark. Okay, so let's see, we know that this function here, got to go back up, there was, it is negative x cubed. So then we know that this graph eventually ends up going down. So we know that it's going to look something like this. It's going to hit up there in the max, come down here, and that's going to be our minimum. It's going to look something like that, right? So here's our 1.15 and our 3.08, and then here's our negative 1.15, negative 3.08 down there. So those are our two. There's our, and let's see, this is a local max, right? And this is our local minimum. All right. Okay, and then last one here, number 5. We've got this function here, and it's got a stationary point at negative 2, 3. We got to find the values of a and b, and then find the position and nature of all the stationary points. So we have this here, and we know that there's a stationary point at negative 2, 3. So we know that the tangent of this stationary point, that the slope of this line, has got to be 0. So if we're talking about slopes of tangents, we want to take the derivative of this thing first, right? So let's try that. So we've got f of x equals x cubed plus ax plus b. If we take the derivative of that, we get, let's see, 2x, subtract 1, so that's 2x to the first, and that's x to the first here. 1 times a is a, and then the x is gone, and then the derivative of the constant b is gone, turns into 0 also. All right, so here's our derivative. So we've got 2x plus a. All right, now again, we know that at negative 2, 3, this thing here has to equal 0 because it's a stationary point. So when x is negative 2, we know that the f prime of x, our derivative, our slope of our tangent line here, is 0. So we got 0 equals 2 times negative 2 plus a. Okay, I have to back up because look, I put x squared here when it was actually x cubed. So that's going to be x cubed, so that's going to make this 3x squared, right? So that's going to be 3 times negative 2 squared. So we got 0 equals, negative 2 squared is 4. 4 times 3 is 12 plus a. So we can actually now figure out what a is by just solving for it. So we get that a is negative 12. So that's one part of it. Okay. So now let's go through, now that we know that a is negative 12, we should be able to plug that in and try to figure out what b is going to be. All right. So let's see. We now know that f of x is x cubed plus negative 12. So let's do minus 12x plus b. All right. So again, let's take the derivative of that. Right, 3, that's going to give us 3x squared, right? Because 3 times 1 is 1, 3 minus 1 is 2. This is x to the first. 1 times negative 12 is negative 12. Okay, and we know, again, that we have a stationary point at negative 2 and 3. So, sorry, scratch that. We don't need to take the derivative. Let's get rid of that. Okay, because what we do know, because again now we know what a is, we know that f of x, that's the same thing as our y, so we know now, that 3 equals, if we plug negative 2 in here, negative 2 cubed minus 12 times negative 2 plus b, and look, b's are only variable, so now we should be able to figure out what b is. So 3 equals negative 8 plus 24 plus b. So let's see, negative 8 plus 24 is 16. So subtract 16 from both sides, and we get that b is going to have to equal negative 13. All right, so now we found a and b. So that takes care of part A. Part B says find the position and the nature of all the stationary points. So let's see if we can figure that out. So we now have we've got the function here with all of, we now know what A and B both are. So we now have our new function, which is, actually it's not new, it's just we have the values now. So it's x cubed plus A, which is negative 12. So let's write minus 12x, and then plus B, which is negative 13, right? Okay, so again, we know we're going to have stationary points in there, so that means the slope of the tangent is 0, so that means we've got to take the derivative. F prime of x is 3 times 1 is 3x. Subtract 1 from that, that's x squared. And then 1 times negative 12 is minus 12, and then the derivative of our constant turns into 0. Okay, so there's our derivative. So if we're trying to find all the stationary points for that, we know that the stationary points again have a slope of 0, so we set f of x equal to 0. 3x squared minus 12. So let's see, we can factor a 3 out of that, and we're left with x squared minus 4. So we have, again, this is another perfect difference of perfect squares, so that's going to be x and x. Factors of 4 are 2 and 2. One's positive, one's negative. So we know that our x's have to equal negative 2 and positive 2. Okay, so we know we have stationary points when x is negative 2 and when x is positive 2. Now look, they already gave us one of the stationary points up here. So we know that we've got negative 2, 3. All we have to do is plug 2 in to our original function up here to figure out what the y value is for that. So let's try that. Okay, so we've got, let's see, it's x cubed. So let's just rewrite the function here. Is x cubed minus 12x minus 13, right? So f of 2 is 2 cubed minus 12 times 2 minus 13. So let's see, that gives us 8 minus 24 minus 13, which 24, 34, 35, 36, 37, negative 37, and 8 gives us negative 29. So now we know the other stationary point is at 2 and negative 29. Now it doesn't ask us to actually graph it. It just says find the position, which we just did, and the nature of the stationary point. So again, if we just really roughly sketch that graph, right, we've got negative 2 and say 3 here, and then we've got 2 and negative 29. So let's just pretend that that's it right there. This is a positive x cubed, so we know it ends up going up. So our graph's going to look roughly something like this, right? So we know that this point over here is a local maximum. So that's the 2, negative 3, so that's a local maximum. And then this one here is the 2, negative 29, and that's a local minimum. Local minimum. Okay? All right, that does it for the 19I assignment. If you have any other questions, please ask in class, and I'll be happy to help you. Thanks.